Today we asked Cortex for an opinion. Does the artificial prefrontal cortex really improve cognition? The important result was not a confident answer. The opinion exposed a doubt, and Cortex turned that doubt into one question that could be tested. The method begins with two coordinates. The theme is the stable direction. Make Cortex an artificial prefrontal control system. The focus is the exact point reached now. Together, they prevent a long investigation from forgetting both its destination and its current position. When a problem matters, Cortex does not explore everything. It asks which uncertainty most affects the goal and can actually be reduced. That decisive doubt becomes the next question to test, the next anchor on the wall. Authorized actions are then compared as paths through a graph. Expected progress and information pull a path forward. Token cost, time, action count, and risk push it back. Unauthorized, irrelevant, and already falsified routes are inhibited. The result is not a magical shortest path, but a measurable preference for the smallest useful step. The critical cycle is explicit: question, hypothesis, action, readback, critique, correction. It runs once, inside a budget and a stop condition. Language can propose. Only observable evidence can close the cycle. That distinction was tested today. 4 model-normalized requests in Italian, English, Spanish, and Japanese reached the same semantic route. A generic opinion did not. A request for continuous autonomy was inhibited. The complete suite passed 232 of 232 node tests and 51 of 51 shell parity tests. The strongest result is also the most cautious. In a live Italian cycle, Cortex selected the paired holdout ablation and rejected an unsupported declaration of victory. Because no evidence was supplied, the verdict remained unverified, and the memory received 0 cognitive anchors. Failure to prove is not converted into learning. Think of a climber planting a piton higher on the wall. The opinion reveals a doubt. The doubt becomes a test. If independent evidence confirms the correction, that correction is saved as a cognitive anchor. The next decision can start from that verified point instead of repeating the same error. The real challenge between artificial intelligence systems is not which one sounds most certain. A capable model recognizes a relevant doubt, turns it into a test, rejects a false conclusion, and corrects its own next step. Scientific doubt suspends an unproved conclusion, makes a testable hypothesis, and accepts correction from evidence. That is operational intelligence. Cortex now implements that bounded, verified route in persistent external state. This is not consciousness, autonomous will, general intelligence, or learning in the model weights.